Hey guys, today's lesson is all about stoichiometry. Stoichiometry is really just calculations involving the mole ratio. So usually you're given an amount of one compound and asked to find the amount of another compound, and you have to use the mole ratio to do that. There are three different types of stoichiometry. There's gravimetric, which just has to do with masses of things. There's solution, which has to do with like volumes and concentrations. And then there's gas stoichiometry, which has to do with gases, usually using things like the ideal gas law. So I'm going to try and get through all three of those types today. Okay, so the first type is gravimetric. So this is the type that has to do with masses. So we're going to have to calculate the mass of a given compound, either a product or a reactant, when given the mass of a different product or reactant. And so to go from the mass of one compound to the mass of another compound in a reaction, we have to use the mole ratio. So like I said, stoichiometry is essentially just finding the relative amounts of different things using mole ratios. Of course, to use the mole ratio, we have to start with a balanced chemical equation so that we can then see the relative amounts of our products and reactants. Gravimetric, like I said, is any time that the masses is what's being calculated instead of like concentration or volume, for instance. In order to calculate gravimetric stoichiometry, you either have to be given mass or be calculating mass. Again, it doesn't really matter what type of stoichiometry you're doing. It all involves mole ratios. So with gravimetric stoichiometry problems, of course, start off with writing out the formulas of your compounds. Make sure that you cross over all of your charges. Write out your chemical equation and balance it, and then find the molar mass of any substance whose mass you were given. You can then find the moles of that substance. That's always kind of the middle step of all stoichiometry problems, is find the moles of whatever you were given information about. You then use the mole ratio to find the moles of the substance you're being asked about. And then if you're being asked for the mass of that substance, you're going to have to find its molar mass to use your moles equals mass over molar mass formula to find mass. Again, this will all make more sense once you do some actual practice calculations. But this is just kind of the pattern of steps that you follow with gravimetric stoichiometry. You always start by finding the molar mass of the substance you were given information about, then calculate the moles of that substance, use the mole ratio to calculate the moles of the substance you're being asked about, and then go back to moles equals mass over molar mass to find the mass of the substance that you were asked for. So we're just going to go through a couple practice questions. I would recommend that you watch me solve like the first practice questions and then try the remaining three on your own and come back to see the solutions. Okay, so for this one, we were told that we have iron 3 oxide reacting with carbon monoxide to produce solid iron and some type of gas byproduct. We were also told that we're going to be producing 130 grams of iron, and it wants to know what mass of iron 3 oxide we need to use in order to do that. So we're going to start by writing out the actual chemical equation for this. So iron 3 oxide will be Fe2O3. Carbon monoxide is obviously just CO. Iron is Fe. And a gas byproduct. So this is going to have to be carbon dioxide. Okay, I know that it's carbon dioxide because if it was carbon monoxide, those would just cancel out. And yet it has to have both carbon and oxygen in order to be over there. Okay, just so you know, in the questions that you're going to be doing, it's much more clear what you'll be producing than that. It won't be that tricky to figure out what's being produced. Okay, so from there, we're going to have to balance it. Okay, so this is what the balanced chemical equation will look like. So I'll put a 3 in front of my carbon monoxide, a 2 in front of my iron, and a 3 in front of my carbon dioxide. I was then given the 130 grams of iron, which means I have to figure out what the molar mass of iron is, and that will just be reading it right off the periodic table, which I have to find. Okay, so iron has a molar mass of 55.845. So now I'm going to solve for moles equals mass over molar mass. So step 1 was my equation. Step 2, my molar mass. Step 3, find my moles. So 130 divided by 55.845 is 2.328 moles of iron. Step 4, because it is asking about my iron oxide, I have to set up a mole ratio between my iron oxide and my iron that I was given the information about. So it is a 1:2 ratio, because those are my coefficients. And then I am solving for X, which is going to be my moles of iron oxide. And I'm given, or I've solved for my moles of iron, so 2.328. So I'll just cross multiply and divide to get 1.164 moles of my iron oxide. And then my final step, step 5, will be to go back to my moles equals mass over molar mass formula. Actually, before I do that, call that step 6. Step 5, I'm going to have to find my molar mass of iron oxide so that I can use my moles equals mass over molar mass formula. So iron oxide is going to be 55.845 times 2 plus oxygen is 16, so 16 times 3 is 159.69. So for step 6, I plug in my moles of iron oxide, plug in my molar mass of iron oxide, and then multiply to solve for mass. And I'll get 185.9 grams of iron oxide as my final answer. Okay, so try the remaining 3 questions on your own and then come back to get the answers. Again, all you're doing is writing a balanced chemical equation, finding the moles of the thing you're given the mass of, mole ratio to the thing you're asked about, and then back to the mass of the thing you're asked about. Those are kind of the 3 main steps, other than just finding molar masses and stuff like that. Okay, so good luck. Let me know if you have any questions. Okay, guys, so here are your answers. For question number 2, it asked for the combustion of butane. So butane, it gave us is C4H10. A combustion reaction always reacts with oxygen, produces carbon dioxide and water. In order to try and balance this, I actually started by putting a 4 in front of my carbon dioxide and a 5 in front of my water to balance with my butane. And then when I tried to balance my oxygen, I couldn't. Anytime you get into that kind of an issue, the easiest thing to do is just double the numbers that you were trying to use. So I turned this 4 into an 8. I turned this 5 into a 10. And I turned the imaginary 1 in front of the butane into a 2, and then I could balance it by putting a 13 in front of the oxygen. You were then told that you had 25 grams of your butane, and it wanted to find the mass of oxygen. With these stoichiometry problems, you're always going to need molar mass for both the thing it gave you the mass of and the thing it's asking for the mass of. So I just right away found the molar mass of both the butane and the oxygen. And then from there, I did my moles equals mass over molar mass to get 0.43 moles of butane. Did my mole ratio, which was a 2 to 13 ratio, which gave me 2.8 moles of oxygen, and then went back to my moles equals mass over molar mass formula to find that I had 89.66 grams of oxygen needed. For question number 3, it told us that we were reacting potassium sulfate, which is K2SO4, with 14 grams of magnesium sulfide. In a double displacement reaction, which is the only thing this could be, I would make magnesium sulfate and potassium sulfide. Then we use our solubility table to identify the precipitate, which is the magnesium sulfate. I then found the molar mass of both my magnesium sulfide, since that's what I was given the mass of, and the magnesium sulfate, since that's what I was asked for them to find the mass of. Then I did moles equals mass over molar mass to get 0.24867 moles of magnesium sulfide. It's a 1-to-1 ratio between magnesium sulfide and magnesium sulfate, which means that it's also 0.24867 moles of magnesium sulfate. And then I plug that back into my moles equals mass over molar mass formula to get 29.9 grams of my precipitate. So as you can see, if you start off with a balanced chemical equation and find the molar masses of the 2 relevant compounds, the 3 big steps then are always just moles equals mass over molar mass, mole ratio, back to moles equals mass over molar mass. And you'll see that pattern again in question number 4, which said that we were reacting hydrobromic acid and calcium hydroxide in a neutralization. So we make water and calcium bromide. I found the molar mass of my calcium hydroxide, since that's what we were given the mass of, and found the molar mass of the calcium bromide, since that is the salt that's produced. After I had my balanced chemical equation and my relevant molar masses, I then just start with moles equals mass over molar mass, and I get 0.2568 moles of calcium hydroxide. Then I do my mole ratio. It's a 1-to-1 ratio between calcium hydroxide and calcium bromide, which means that I have 0.2568 moles of calcium bromide as well. So I plug that into the moles equals mass over molar mass formula again to solve for 51 grams of my salt. Okay, so that is it for the gravimetric stoichiometry. Again, all you do is write and balance your chemical equation, calculate your molar masses, and then you do moles equals mass over molar mass, mole ratio, back to moles equals mass over molar mass. Very straightforward. Okay, solution stoichiometry is going to be very similar to that. Again, this time, instead of calculating masses, we're going to be calculating either volumes or concentrations, and we will be given either volumes or concentrations. Once again, we always have to start with a balanced chemical equation and then use the mole ratio to convert between the moles of the thing we're given information about to the moles of the thing we're asked for information about. So it's going to be very similar. Again, we're going to start with our balanced chemical equation. This time, instead of using moles equals mass over molar mass, we're going to be using C equals N over V. And then once again, mole ratio, and then probably back to C equals N over V. So let's just try these problems. Again, I'll walk through the first one with you, or you can watch me walk through the first one with you. And then from there, try the remaining 3 on your own. Okay, so for the first problem here, it says that we have lead to nitrate, which will look like that. My lead's charge is crossed over outside of my nitrate. My nitrate has a charge of -1, so we don't bother writing it in. It's going to react with sodium iodide, and it wants to know what volume of the lead nitrate. So I'm trying to find the volume of the lead nitrate is going to be needed to completely react with 900 milliliters of 0.4 molar sodium iodide, and we're told that our lead nitrate is 0.2 molar. So from there, I'm going to figure out what my equation is. So this must be a double displacement reaction. So I'm going to end up with sodium nitrate, which is NaNO3, and lead 2 iodide, which is PbI2. Then I'm going to need to balance this by putting a 2 here in order to get my nitrates balanced, and then a 2 here to balance my iodide and my sodium. So that's our balanced chemical equation now. Once I have my balanced chemical equation, I just go to C equals N over V because I'm given both concentration and volume. I'll plug in my concentration, that's my 0.4 molar. I'm solving for my moles, and then my volume, 900 milliliters, does have to be converted into liters to go into my C equals N over V formula. And then I'll just times by 0.9. So 0.4 times 0.9 is 0.36 moles, and that is of my NaI. Step 2 is a mole ratio between my lead nitrate and my sodium iodide, which is a 1:2 ratio. I'm trying to find my moles of lead nitrate, and I have 0.36 moles of sodium iodide, so I will just cross multiply and divide. Which gives me 0.18 moles of my lead nitrate. And then my last step is to go back to C equals N over V because I'm given concentration of lead nitrate and asked for volume. So I'll plug in my concentration of 0.2. I will plug in the moles I just found, 0.18, and I will solve for V. Now remember, when you're solving this, whatever's on the bottom of the fraction has to move. So I'm going to multiply by V, which gets me 0.2V equals 0.18, and then I divide by the 0.2, which gives me 0.9 liters as my volume of lead nitrate. In this case, it turned out that the volume of lead nitrate that I needed was the same volume of sodium iodide that I started with, but that won't always be the case. Okay, so those are kind of the main steps. We start with a balanced chemical equation, then we just do C equals N over V, mole ratio, back to C equals N over V. So try that with the remaining 3 questions and then come back and check your answers. Okay, so for question number 2, you were told that it was a neutralization reaction between hydrogen sulfate, also called sulfuric acid, and sodium hydroxide, which will of course make water and sodium sulfate. And then we balance it with a 2 in front of our base and a 2 in front of our water. Then, because we were given both the concentration and volume of our acid, we will start with C equals N over V and plug in our concentration and our volume in liters and solve for N. So we get 0.416 moles of our acid. Then we set up our mole ratio between our acid and our base, which is a 1:2 ratio, and we will get 0.832 moles of sodium hydroxide. And then we go back to C equals N over V. This time we were given the volume, so we plug it in liters. And we also plug in the moles that we just solved for. And when we divide, we get a concentration of 2.77 molar of our sodium hydroxide. Question number 2 said that there was a reaction between silver nitrate and aluminum chloride. That would be a double displacement reaction, so we make silver chloride and aluminum nitrate. And then we were given both the concentration and volume of our aluminum chloride. So we'll start by plugging those into our C equals N over V formula, and we get 0.24 moles of our aluminum chloride. Then we set up a mole ratio between the silver nitrate and the aluminum chloride. It is a 3-to-1 ratio. So you should get 0.72 moles of silver nitrate. Then I go back to C equals N over V. I plug in the concentration I was given, plug in the moles that I just solved for, and then isolate V. Again, you do that by multiplying by V and then dividing by 0.8, and you'll get 0.9 liters as your volume of silver nitrate. And for the last question, this one was a bit tricky because of how it was worded. It has barium chloride reacting with sulfuric acid, and it's making hydrochloric acid. And then because this is a double displacement, you will also make barium sulfate. It then gives you that we have 4 liters of the barium chloride, 6 liters of the sulfuric acid, and it tells us that our precipitate, which is the barium sulfate, will have a negligible volume, which means it will have a volume of 0. The one trick here is that you have to realize that that means your volume of hydrochloric acid that you make is 10 liters, because you have the 4 liters from the barium chloride and the 6 liters from the sulfuric acid. Since none of that is becoming precipitate, we are assuming all 10 of those liters are becoming hydrochloric acid. It then gave us the concentration of hydrochloric acid and asked for the concentration of our hydrochloric acid. So we start with C equals N over V, as usual, and plug in our concentration and our volume of our sulfuric acid, and you should get 48 moles of sulfuric acid. It is then a 1-to-2 ratio between sulfuric acid and hydrochloric acid, so you should get 96 moles of hydrochloric acid. And then you go back to C equals N over V, plug in the moles that we just solved for, plug in our 10 liters, and when we divide, we get 9.6 molar as our concentration of hydrochloric acid. Okay, so the final type of stoichiometry is gas stoichiometry. For this one, you can be using any of the gas laws that include an N as one of the variables. So in this case, you're once again going to be using the mole ratio, but instead of using moles equals mass over molar mass or C equals N over V, you'll be using some of the gas laws instead. So just a reminder of some of the gas laws, we have the ideal gas law, which is PV equals nRT, where P is our pressure, V is our volume in liters, N is our mole, R is the constant, and again, those numbers are given to you on your formula sheet, and then T is temperature. Don't forget your temperature has to be in Kelvin. Avogadro's law is the one that has volume and moles over top of each other, so this is only useful if you're only given volume. And then molar volume can only be used at STP or at SATP, but as soon as you see that it's happening at STP or SATP, check and see if you can use molar volume. So in this case, V is the volume in liters, N is the moles, and then the VM is your molar volume, and it will be either 22.4 if it's at STP or 24.8 if it's at SATP. So let's just once again walk through the first example together, and then you guys can try the next 3 on your own. Okay, so for the first question, you were told that you had CH5OH combusting completely. Now, combustion reactions always have oxygen as the other reactant, and it always makes carbon dioxide and water. And then it also tells you that you have 220 grams of your hydrocarbon, that the pressure is 105 kilopascals, and that the temperature is 23 degrees Celsius, which right away you should convert to Kelvin. So add 273.15, and you'll get 296.15. Our second step is then to balance our equation. And our balanced chemical equation will look like this. So I started by making sure my carbons were balanced. Then I tried my hydrogens, and I have 6 hydrogens on the reactant side, which means I need to put a 3 here to get 6 hydrogens on the other side. Then I counted my oxygens. I've got 5 oxygens on my product side. And so if I put a 2 in front of the oxygen here, I now have 4 plus 1 more, 5 oxygens on my reactant side. So that's what the balanced chemical reaction looks like. The next thing that I'm going to see is that I was given the mass of something. Anytime that I'm given the mass of something, it means that I can convert it to moles using moles equals mass over molar mass. So my next step is going to be to figure out what my molar mass of my hydrocarbon is. So I'm going to take the 12 for the carbon plus 16 for the oxygen plus 6 for all of the hydrogens, and I get 34 as my molar mass. That means my first step can actually be moles equals mass over molar mass. Again, anytime I see grams, I'm thinking of this formula, my moles equals mass over molar mass formula. So I'm going to plug in my 220 grams divided by my molar mass of 34. And I get 6.47 moles of CH5OH. Step 2, I'm going to use my mole ratio. That's like always the middle step of stoichiometry. So I'm going to go between my hydrocarbon and my carbon dioxide, since that's what it's asking me about. This is a 1-to-1 ratio, which means that I'm going to have 6.47 moles of carbon dioxide. Now, so far, everything is just like we've done on the other 2 types of stoichiometry. The only difference here is that instead of asking for mass, it's asking for volume. Because it's not asking for mass, I cannot use moles equals mass over molar mass. And because it's asking for volume, and yet I was not given concentration, I cannot use C equals N over V. So instead, I'm going to take a clue from the fact that I was given pressure and temperature and try using PV equals nRT, my ideal gas law. So I'll plug in my pressure of 105 times V, which I'm looking for. I'll plug in my moles, which is 6.47. Because my pressure is in kilopascals, 8.314 is going to be my R value, and then my T is 296.15. Sorry, I'm running out of room, but it's written right there. And then I'm going to divide by 105 to isolate V. So 6.47 times 8.314 times 296.15, all divided by 105 gives me 151.7 liters of carbon dioxide. Okay, so try the other 3 problems and come back to check your answers. Okay, so for question number 2, we were told that we were combusting the C2H6, our ethane, and that we had 330 grams of it, and it wanted to know how much oxygen was required. So I start by writing out my equation. I know that I'm making carbon dioxide and water because it's a combustion reaction, and then I balance it. I started by putting a 2 here and a 3 here to balance with my C2H6. Realized that my oxygen wouldn't balance, so then doubled my 2 to a 4, doubled my 3 to a 6, and doubled my imaginary 1 to a 2, and then I was able to balance my oxygen. Like I said, anytime I see grams, I think moles equals mass over molar mass. So I calculate my molar mass of my ethane, and then I can plug the mass and the molar mass into moles equals mass over molar mass and get 11 moles of methane. Then I set up my mole ratio. It is a 2-to-7 ratio between ethane and oxygen. And I plug in my 11 moles of ethane, and I solve for 38.5 moles of oxygen. Then because I'm told that this is happening at SATP, I know that I can use my V equals NVM formula. I plug in my 38.5 moles of oxygen, multiply by 24.8, which is the Vm, and I get 954.8 liters of oxygen. You will notice that with a lot of gas stoichiometry problems, your answers are very, very large, and that's because gases take up a lot of space because they spread out so much. Okay, so question number 3 is a little bit different. It doesn't use the mole ratio per se because Avogadro's law formula is really a mole ratio in and of itself. So anytime all that you're given is volume and all that you're asked for is volume, if that is the only information you have, then Avogadro's law is the formula to use. So I start by writing my balanced chemical equation, which is that we have 1 nitrogen plus 3 hydrogen becomes 2 ammonia. Don't forget our nitrogen and hydrogen are diatomic. And then I use Avogadro's law formula. I plug in the mole ratio at the bottom here, which is why this is kind of a mole ratio on its own. So the imaginary 1 from in front of the nitrogen gas, the 3 from in front of the hydrogen gas, and then I plug in my volume of hydrogen gas and solve for the volume of nitrogen gas. When I cross multiply and divide, I get 4 liters of nitrogen gas. And then the last question here said that we have carbon dioxide reacting with hydrogen gas to make water and CH3OH. We're wanting to produce 600 grams of the CH3OH. It wanted to know how many liters of hydrogen gas we would need for that. It also told us that our pressure was 1.2 atmospheres and the temperature was 18 degrees Celsius, which don't forget, your very first thing when you see degrees Celsius is converted into Kelvin. So it's 291.15 Kelvin. Again, anytime I see grams, I think moles equals mass over molar mass. So I found the molar mass of my CH3OH, which is 32. I then plug the 600 grams and the 32 into moles equals mass over molar mass, and I find that I have 18.75 moles of CH3OH. I then set up my mole ratio between my hydrogen gas and my CH3OH. It is a 3-to-1 ratio. And then I plug in my moles of CH3OH and cross multiply to get 56.25 moles of hydrogen gas. Then because I'm given pressure and temperature, I can use my PV equals nRT formula. So I plug in my 1.2 atmospheres for my pressure. My V for volume is what I'm solving for. I'll plug in my 56.25 moles of hydrogen gas. Because my pressure is in atmospheres, I'll be using 0.082 as my R value, and then my temperature in Kelvin, 291.15, divide it all by 1.2 to solve for V, which is 1119.1 liters. So that's it for stoichiometry. Let me know if you have any questions. Let me know if I've done something wrong in one of these problems, because that could very well happen. And yeah, I look forward to hearing from you.